Welcome back to the Deep Dive. We have a really fascinating stack of documents to get through today. On the surface, if you just glance at the top page, it looks a bit like a cheat sheet. You know, a list of essential interview questions for SAP ABAP developers.
It definitely has that final exam cram session vibe to it, doesn't it?
That does. But as I started, reading through these definitions, really digging into the notes and the explanations, I realized we're not just looking at a quiz. We're looking at the blueprints for how the global economy runs.
That's not an exaggeration.
I mean, SAP systems process something like, what, 3/4 of the world's transaction revenue? And ADA, that's the language making it all happen.
That is exactly the right way to frame it. I mean, if you just memorize these definitions, sure, you might pass a junior developer interview. But if you understand the why behind them, you actually understand enterprise architecture. You start to see how data flows, how concurrency is handled, and how a massive monolithic system keeps from, collapsing under its own weight when thousands of users are hitting it at once.
Exactly. So our mission today is to take these kind of dry definitions and reverse engineer the architecture of an SAP system. We should probably start with the language itself, ABEP, Advanced Business Application Programming. The source calls it a high-level language. But practically speaking, if I'm an SAP developer, what am I actually building with this?
You're building the business logic. Think of the SAP system as a massive prefabricated office building. It comes with the walls, the plumbing, the electricity, all the security systems already installed. But ABAP.
That's the customization.
ABAP is what you use to build the specific furniture, the workflows, the customer ports, and the interfaces that make that office work for your specific company. It's the tool for reporting, forms, and crucially for enhancing the standard behavior of the system. Right.
And the source material, it categorizes the tools in your build into 4 specific program types. We have report programs, module pool programs, function modules, and class program. Let's break these down.
Yeah, because the distinction really dictates how a user actually experiences the software.
It seems like it.
So let's start with the most common one, report programs. This is your bread and butter for output. Think of a report program as like a query. You ask the system a question, show me all invoices from last week, and it gives you a list.
Okay, so it's linear. Input, processing, output.
Exactly. It's a monologue. The system talks to you.
Versus the module pool programs. The source describes these as being for dialogue screens.
Yeah, and dialogue is the key word there. It's a conversation. A report is a monologue, but a module pool is where you talk back. You're navigating screens, clicking tabs, entering data, validating fields in real time.
So if I'm a shipping clerk entering a delivery.
You're probably in a module pool program. Yeah, it handles the entire flow of the user interface. What happens when you click next? What happens when you hit enter? All of that.
Okay, so that's the user-facing side. Then we have function modules and class programs. The source groups these under reusable logic.
And this is about efficiency and, quite frankly, sanity for the developers. Let's say you have a complex formula to calculate sales tax in Brazil.
Oh, I've heard stories about that.
The tax laws are notoriously complicated. You do not want to write that code in every single report, in every single screen that deals with money.
No, you'd have a maintenance nightmare on your hands. If the tax rate changes, you have to find every single program where you wrote that code.
Exactly. So you encapsulate it. A function module is the classic way to do this. It's a standalone block of code. You feed it inputs, it crunches the numbers, and it spits out outputs. Any program in the system can call it. You write it once, maintain it in one place, use it everywhere.
And class programs, that brings us into object-oriented ABAP, right?
Right, and this is where the interview questions list kind of hints at the evolution of the language. ABAP started very procedural, step 1, step 2, step 3. Class programs introduce object-oriented programming, so bundling data and behavior together into objects.
Which is vital for modern apps.
It's vital. It makes the code much easier to manage, test, and extend over time. It's the difference between, say, a loose collection of tools and a well-organized toolbox.
So we have our programs, our logic. But logic is useless without data. And this is where the source material gets really heavy on the data dictionary, or T-code SE11. It calls it the central repository.
If you're an ABAP developer, SE11 is your home address. You probably spend more time there than in your own living room. And it's not just a list of tables. It is effectively the constitution of the system.
The Constitution. That's a big claim.
I say that because it defines the laws of the data. In many other programming languages, you might define a variable loosely in your code. In SAP, the data dictionary enforces consistency globally. It defines what a material number looks like, how long it is, what characters are allowed. It ensures that if 5 different programs try to look up a customer, they all agree on what a customer actually is.
It prevents chaos.
It prevents chaos, exactly.
Speaking of tables, the source highlights transparent tables. It gives examples like MERA, VBAK, and VBAP. Why the specific focus on transparent?
It's a transparency to the underlying database. When you create a transparent table in the ABAP dictionary, SAP automatically creates an identical table in the physical database, whether that's Oracle, SQL Server, or HANA. It's a one-to-one mapping.
And those examples, MERA, VBAK, those are some of the heavy hitters in the SAP world.
The holy trinity of logistics. MRI is the material master. That's every product you buy or sell. VBAK is the sales order header, the who and when of a sale. And VBAP is the item data, the what and how much. If you work in SAP logistics, you are querying these tables constantly.
They're the backbone.
They are the backbone of the sales process.
Okay, so that's the data at rest. It lives in the database, but the source makes a massive deal, maybe the biggest deal in the whole document, about the difference between database tables and internal tables. It feels like this is the crux of ABA performance.
It absolutely is. This is the single most common failure point for junior developers. If you don't understand this distinction, you will write code that crashes the server.
The distinction seems simple on paper. Database tables are permanent storage. Internal tables are temporary memory.
Simple definition, but with a complex implication. Think of it like cooking. The database is the grocery store. It has all the ingredients you could ever need, stored permanently on shelves. But you can't cook a meal standing in the aisle of the grocery store.
That would be frowned upon, yes.
Exactly. So you go to the store, you pick the specific ingredients you need, and you bring them home to your kitchen counter. That kitchen counter, that is your internal table. It's a temporary workspace in the application server's memory.
Okay.
You fetch the data you need from the database, the store, load it onto your counter, the internal table, and that is where you work. You chop, you mix, you season. That's the calculations and loops part.
And accessing your kitchen counter is obviously much faster than driving back to the store every time.
Infinitely faster. The drive to the store, the database access, is the most expensive part of the process in terms of time. The cardinal sin of ABA is something called select inside a loop. That's like driving to the grocery store to buy one egg, driving home, cracking it, then driving back to the store for a pinch of salt.
It's just wildly inefficient.
It's insane. You want to go to the store once, get everything, and do work on the counter.
That makes perfect sense. Now, the source goes deeper here. It mentions 3 specific types of counters or internal tables available: standard, sorted, and hashed. This isn't just trivia. This impacts speed, right?
Drastically.
Oh.
A standard table is just a pile. You throw data on top. If you want to find a specific record, say invoice 500, you have to look through the pile one by one. It's a linear search. If you have 100 records, it's fine. If you have 1,000,000, your program hangs.
Okay, so that's where the sorted table comes in.
Right. It's like a filing cabinet. The data is automatically kept in order as you insert it. And because it's sorted, the system can use a binary search. It cuts the deck in half, checks if the number is higher or lower, cuts it in half again. It finds the data much, much faster.
But the source lists hash tables as the fastest.
Hash tables are basically magic. They use a hashing algorithm to calculate exactly where the data is stored in memory. It doesn't matter if you have 10 rows or 10 million rows. Access time is constant. You give it the key, it gives you the record instantly.
So why not just use hash tables for everything if they are instantaneous?
Because they're rigid. You can only access them by their unique key. And crucially, you can't have duplicates. If you try to insert 2 records with the same key, the program dumps, it crashes. So standard is for flexibility, sorted is for range scans, and hashed is for rapid single record access. Knowing which one to pick is what separates a coder from an engineer.
Got it. And to finish this whole data handling concept, there's one last term: the work area.
The work area is your hand. You have the pile on your counter, the internal table, but you can only read or chop one item at a time. The work area is that single structure holding the one row you're currently processing. You move a row from the table to the work area, do your logic, and then move to the next.
Okay, moving on to how we actually get that data from the grocery store to the counter. The source mentions OpenSQL. I found this interesting because it says it's database independent.
That's the beauty of SAP's architecture. It's an abstraction layer. Your company might run on an Oracle database today, but decide to switch to Microsoft SQL Server tomorrow. If you wrote native Oracle SQL in your code, your system breaks immediately upon switching.
You'd have to rewrite millions of lines of code. That sounds like a disaster.
It would be. So instead, you write OpenSQL. It's ABAP's standardized version of SQL. The ABAP runtime takes that code and translates it on the fly into whatever dialect the underlying database speaks. It protects your code from the hardware. It makes the application portable.
That's smart. Now, once we have the data, we need to show it to the user. The source contrasts classical reports with ALV.
Classical reports are relics. Think green screen lists, just text on a screen. Hard to read, hard to format, and ugly to print.
And the ALV, ABAP list viewer.
The ALV is like embedding Excel inside SAP. You throw your internal table at the ALV function, and it renders a beautiful grid. But the best part is the functionality it gives the user for free. They can sort columns, filter, sum up totals, move columns around.
And the developer doesn't have to code a sort button or a filter button for all that.
Zero code for that. It's standard. If you are building a report today and you don't use ALV, you're doing it wrong. It saves you time, and the users love it.
Before we leave the coding section, the source mentions debugging. It calls it finding and fixing errors using breakpoints.
Debugging is the detective work. It's actually one of the most powerful tools in SAP. You can literally pause the program in the middle of execution. That's the breakpoint. You freeze time. Then you can look at your internal tables, check the variables in your work area, and see exactly why the logic went left when it should have gone right.
It's like a frame-by-frame analysis.
Exactly. You're stopping the movie to see what went wrong.
Let's shift gears to connectivity. This is a huge part of the enterprise world of systems, talking to systems. The source lists RFC and BAPI. These 2 acronyms get used interchangeably all the time, but the source insists there's a difference.
There's a critical difference. Think of it like a telephone call. RFC, or remote function call, is the technology. It's the telephone line and the connection itself. It allows system A to execute code on system B.
Okay, so RFC is the line. What is BAPI?
BAPI, Business Application Programming Interface, is the official language spoken over that line. It's a specific type of function module that SAP has guaranteed is safe to use for integration.
Safe implies there's a dangerous way to do it.
Oh, absolutely. Let's say you want to create a sales order from an external website. You could technically write a script to just insert rows directly into the VBAK and VBAP tables we talked about earlier.
Direct table updates. Sounds risky.
It's strictly forbidden. If you do that, you bypass all the checks. Does the customer exist? Is the material in stock? Is the credit limit exceeded? You skip all of that and you corrupt the database.
So the BAPI acts as the bouncer.
Exactly. The BAPI, like Babe Piesel store to create from DAT2, that's mentioned, takes your data, runs all the validations, checks the business rules, and then inserts the data safely. You use the RSC technology to call the BAPI logic.
That clarifies it perfectly. Now, speaking of multiple users and safety, lock objects.
This is about the race condition. Imagine you and I are both looking at the same customer record. I want to update their phone number. You want to update their address. If we both hit save at the exact same millisecond without locking, the system might try to process both, or one might overwrite the other without knowing. Lock objects prevent this. When I enter edit mode, the system sets a lock. If you try to edit, you get a polite error message. User is currently processing this object.
It forces sequential processing.
Crucial for data integrity. You can't have two people driving the same car at the same time.
Now, we've established that SAP is a standard house, but everyone wants to renovate. The source talks about enhancements, user exits, customer exits, be by eyes. Why so many different ways to change the system?
It's an evolutionary timeline. In the old days, SAP gave us user exits, essentially empty subroutines in their code where we could add our own logic, but they were messy. If two developers tried to use the same exit, they'd overwrite each other.
Then came customer exits.
A bit more organized, packaged in projects, but the real modern standard is the BAI, the business add-in. It uses that object-oriented technology we mentioned. It allows multiple implementations. So if I want to add a check for US taxes and you want to add a check for German shipping rules, we can both implement the same BABI without breaking each other's code.
And the golden rule here is don't modify the standard code, right?
Never modify the core. If you change SAP's source code, the next time you upgrade the system to a newer version, the upgrade will just wipe out your changes. Enhancements are designed to act like hooks. They survive the upgrade process.
Which leads us to moving code around. Transports. The source describes moving from development to quality to production.
This is lifecycle management. You never, ever code in the production system. That is just reckless. You write code in a development environment, you put it in a transport request, think of it as a locked shipping container. You put your tables, your code, your screens in the container. Then the basis team moves that truck from development to the quality assurance system.
Where users test it?
Right. They bang on it, try to break it, and only if it passes there does the container move to production. It ensures that the code running the business has been vetted. It provides a full audit trail.
Just a quick definition before we move on T-code.
Transaction code. It's just a shortcut. Instead of navigating through 5 layers of menus to find the data dictionary, you just type SE11 in the command box and boom, you're there. Every program in SAP has a T-code. It's how power users navigate the system.
Okay, we've covered the classic foundations. But the source material takes a sharp turn at the end into the new world. S4ANA. It mentions changes in forms, but specifically it dives into CDS views and AMDP. This feels like a paradigm shift.
It is the biggest shift in SAP's history. Everything we just discussed, internal tables, loops, bringing data to the kitchen counter, was based on the idea that the database was slow and the application server was fast.
Because traditional databases were spinning disks.
Exactly. But ADANA is an in-memory database. It is incredibly fast. So the new philosophy is code pushdown.
Code pushdown. That sounds like a wrestling move.
It feels like one for old school developers. It means pushing the logic down to the data. Instead of bringing a million records to your desk to sum them up, you send the instruction to the library. The library, the HANA database, sums them up in milliseconds and just hands you the total.
So CDS views, core data services, are how we do that.
Yes. A CDS view looks like a table, but it's actually a complex query with calculations, associations, and logic built right into the database layer. It's virtual, it calculates on the fly. You're not storing the result, you're calculating it the moment you ask for it. And because it's in HA, it's instant.
And AMDP. ABAP managed database procedures.
That's the heavy artillery. That allows you to write SQL script, the native language of the HA database, directly inside your ABAP class. You're bypassing OpenSQL, you're tearing down the abstraction layer and talking directly to the engine for maximum speed.
It's interesting. The source contrasts this with the old Smart Forms versus Adobe Forms too.
Same theme, modernization. Smart Forms were proprietary and clunky to design. Adobe Forms use standard PDF technology, have better design tools, and are form-filling ready. It's about fitting into the modern IT landscape where PDF is king.
So looking at this whole picture, we started with S11 and standard tables and ended with SQL script and ANA. It seems like the role of an ABAP developer is getting broader.
Much broader. 10 years ago, you could survive just knowing loops and internal tables. Today, you need to know when to use the classic approach and when to use CDS views. You need to understand database architecture, not just syntax.
It's not just about making the code work, it's about making it performant in a hybrid environment.
Precisely. The essential interview questions aren't just checking if you know the acronyms, they're checking if you know which tool to pull out of the box. Do I use a BAPI or a direct update?
BAPI.
BAPI. Do I use a standard table or a hash table? Do I process this in ABA or push it down to HANA with AMDP?
That's the mark of the senior consultant. Knowing what to do is easy, knowing why and when is the hard part.
It is, and that's what these sources are really trying to teach.
Here's a thought to leave our listeners with. We spent a lot of time today talking about the kitchen counter, the internal table, as the heart of ABAP processing. But with S4HANA pushing logic down into the database with CDS and AMDP, are we looking at a future where the internal table becomes irrelevant?
That is the million-dollar question. I don't think they'll ever disappear completely. You always need a workspace, but the days of select everything into a table and loop through it might be numbered. The database is taking over the heavy lifting.
A fascinating evolution for a language that's been around for decades, something to mull over. Thanks for joining us on this deep dive into the nuts and bolts of SAP.
Always a pleasure to look under the hood.
See you next time.